Hello friends, we are going to continue the next portion of the leveling, that is profile leveling and the reciprocal leveling. These are the types of leveling. Already we have seen about what is profile leveling in the previous videos. Profile leveling, which yields elevation at definite points along a reference line. That is, if I want to have the profile of this terrain, for that I do a survey with respect to the dumpy level, and I try to plot those elevational values or a graph or sheet. Then I can obtain the longitudinal profile. Suppose that profile, in that longitudinal profile, I need to have a cross-sectional view of a particular point, how it is. For example, say in a road, the road will be approximately this way. So I want to see the cross-section, where to fill, where to cut. For that also can be done. The both the thing in profile leveling, the longitudinal section and the cross-section are the types. Right? Profile means longitudinal profile, cross-sectional profile. Right, the procedure for the both the thing are same, but along the center line, if the survey goes, it is longitudinal profile. Perpendicular to the center line, that is the cross-sectional profile. The readings taken based on that, it will be plotted in the table and the calculation will be made. We will see what they are. Profile leveling, it's a graphical representation of the ground point on a longitudinal section along the alignment. Along the alignment here means the center line. It is being used to determine the depth of cutting or filling on the proposed gradient. To study grade crossing problems, to select appropriate grade, to locate depth of sewer, everything, this profile is required. These are the application of it. Predominantly highways, railways and canals, they do the profile leveling. In this, a datum line is drawn along which distance from one point to other point. That for that distance, a datum line will be drawn, the common datum line, and from that how the terrain. It may cross over the datum or it may be above the datum also, no issue. Right? Which the distance of the stakes are marked and RL are plotted along vertical lines drawn on the mark point. Segmented straight lines joining the RL points represent the longitudinal profile of the ground surface. Profile is generally drawn so that the vertical scale is much larger than the horizontal scale. Since we required the profile with respect to the elevation, that distance has to kept more, so in that vertical axis, that scale will be more compared to the horizontal. Right, so this is an example for a longitudinal profile leveling. Say there is a terrain, we can see from the side of that terrain it is look like that, but we want to plot exactly how the terrain is. So from A to B, and it goes on up to next point, up to C. Right, so we try to keep the instrument in the side of that terrain. Say this is the top view, it look like a straight line. From A to C, it looked like A to C, it is like a straight line, but from the side only the profile will be visible. So the instrument also kept aside of that terrain. Right, from one position, how many maximum point we can cover. Right, so here they kept the interval as 10 meter once. It may be reduced to 5 meter or even 1 meter if the terrain is totally undulated. Based on the terrain, we can fix the gap. Right, so the benchmark of the first point was known, it is 105.61. Over that leveling staff was holded and the staff reading was taken, it was 3.005. From that, wherever the point we need to get the profile, there and all the leveling staffs were holded and the staff readings were taken over that. Up to B, the visibility of the leveling staff was better. Next, we need to shift the instrument. Then the instrument was shifted such a way that the last reading taken from the first portion should be visible, and if possible the last reading of the total profile, if it is visible, well to do, or otherwise we can put one more change point, no issue. From that also the back side and the remaining intermediate side and the last four side were taken. All the readings were taken. Here there is a totally change. See the 10 meter interval, but apart from that there is a small sudden change there. The staff was holded, it is not 10 meter, it is less than that. We consider that distance may be x, the point also considered as x, right? So this profile readings were noted down the level book in the tabular format. From the tabular format, the elevation value of each point with respect to the standard benchmark was calculated and the profile were plotted, and the final result will be like this, but we obtain the bottom only. With respect to this data, we try to project this. So how it was plotted? From 0 to 10, all the 10 meter intervals, it is the horizontal scale which was kept. The datum, standard datum we fixed as 104 meter. Above that, what are the readings? This, all the points red markings are 104 on that profile, right? From 104, the first one, what is the reading? The benchmark already we know, it is 105.615. So 105.615, it is more than that, 1.5 something it is, right? The benchmark, right? Next, the reading we are having. From here we obtain the height of the instrument. From that height of instrument, we have to reduce all the point to get the elevation of those point. Already we know from the height of instrument method, same procedure is adopted. And for the next 10th meter, what is the RL value? We try to plot. Similarly, already I have shown there is a change over here, a small, the X point also the staff reading was taken, right? There, here also there is a drop, that point also get marked. So if you join those points, you will obtain the profile of the line. The bottom portion, we can have a small polygon, so we can calculate those area. If you want to lay a road in this way, how many area to be filled, how much volume of soil has to be cut, how much volume of soil has to be filled, that can be calculated with this, right? So here you will get the area. If you use the cross section also, there you will get a particular cross sectional area. If you combine both the things at each point, you will can get the volume of that, right? So for estimating those things, this profile leveling is more capable, right? So with respect to proper scale and proper marking, you will obtain the longitudinal profile. Similarly, cross sectioning, in many projects, terrain information transfers to the longitudinal section, that is perpendicular to the center line. The longitudinal section we have seen the side view. If you try to get the cross sectional view, that is the transverse direction of the longitudinal section. It is also required mainly in highway, railways, canals, etc. In those cases, surveying is carried out at right angles to the center line. Generally, at regular interval is being carried out. Same 10 meter or 1 meter or 5 meter, whatever the distance we can carry. But in the cross sectional, in the center line, in both the left and right of the road, the center line of the road, the left and right of the road, we need to take the readings. If the width of the road is broader, in the left side we may have 3 points, here 3 points. If it is a smaller road, we may have 2 or 1, right, based on the width of the road. So the observations are then recorded as being to the left or right of the center line. The notes of the readings are maintained as shown. Here is a sample table was shown. Here it's the continuation of the previous profile only. We have taken the cross section at the stake point 4. What is stake point 4? This is the point 4. In this point we try to get the cross section, right? See, this point we try to get the cross section. How? This way it looks, or this, that. Plotting can be done as in case of profile laying. The plotting of cross section is shown. You will see at the stack point 4 from A to B, the longitudinal profile was going. At the particular point, we try to get the cross section of it, right? 0 plus 30 meter distance. Why 30? See, 10, 20, 30 meter is gone. So this point is 30 meter, 0 plus 30. At that point, here the backside is on the benchmark only, the benchmark reading. So benchmark plus backside gives the height of instrument. At the stack point 4, we have to take from the center left, right. The center of the road is 0 meter consider. There the staff reading was down, height of instrument minus this, you will get the RL of the center of the point left. Here they maintain 2 meter interval in the left and 2 meter in the right. So in this 2 meter 4 6, 2 meter 4 6, right. On each point the staff readings were taken and their RLs were calculated, and next point is next 10th meter is 0 plus 40. There we closes the survey for the particular cross section, but it may be continued for the next also. So that backside, right. So this is the cross section. This is the center line, center point 0, left 2 meter, 4 meter, 6 meter. Similarly 2 meter, 4 meter, 6 meter. A profile of a cross sectional profile of the particular road or canal or railway track to be laid, right. So it was plotted. Here also the common datum was maintained. Above that we try to plot with respect to the scale, right. This is the cross section along stack 4, right. Next is the reciprocal leveling. Already we give a small intro about it. When the elevation of the 2 point is required, but each point are either side of a river, we can't set up the instrument over or inside or the top of the river. So the distance may be high, the error may occur. To get rid of that error, what type of error may occur? The line of sight, it may long, it may bend due to refraction, it may upwardly bend, or due to some collimation errors, different types of error may occur. So based on that, the error in the staff reading which we are seeing through the telescope may be differ. So to get rid of that, we try to set up the instrument at one end, take the staff reading nearby, and from that position itself we tried to get the staff reading at the other end by holding the staff, and the same procedure was repeated by transferring, or the second instrument can be used and it kept at the other end here. Then this point become the nearby. From here the staff was holded here, the staff reading. So from the instrument to the nearer point, reading will be errorless or even zero error. Similarly here the error will be less, but from this position to this point the error may be. Similarly here these two error may get compensated. That is the reciprocal level, right? This is the way of survey, direction of survey. This is the flow of water, right? This is the flow of water, right? To find accurate relative elevation of two widely separated intervisible ones. The points are visible, but we can't keep the level. We can't set the level. That is the reciprocal leveling. So to find the difference in elevation between 2 points, say x and y, we will show in the figure. A level is set up at L, which is nearer to x, and the readings were taken. x1 is nearer and y1 on the other side of the water body are observed with the staff on both x and y. Similarly, the level is then set up at y on the other side. From that y, the staff readings were taken, x2, y2, right? The y2 is now become the nearer one. If the differences in the set of observation are not same, then the observations are fraught with errors. The errors may arise out due to curvature of the earth, or associated with the variation in the temperature and refraction, or due to the collimation in the error, right? Or all the combination may occur. So this is what the instrument is set up at L, the staff was holded at x, the elevation point to be determined, or it may be known. The staff reading taken over is the x1, here it is marked as x. If the position of the instrument is L, it is x1, y1. Then the instrument is shifted here. From here the same reading was taken, so here it is y2 and here x2. From the position L, here it won't be no error, but due to the line of sight depression due to curvature of the earth or refraction of the line of sight, or by temperature, whatever it is, any combination, there will be, actually it should be cited in the leveling stuff, but we may see here. So there is a difference. Similarly from here also, so the same way it may occur. So the same error distance will be here. So these two error will get compensated. Have you understood that? So this is the main advantage of reciprocal leveling, that is we can avoid the error, right? The two true difference in elevation and errors associated with observation, if any, can be found out as follows. This is the procedure. Listen students, you try to don't by God, try to understand. This has to be used in the problem solving. Let the true difference in elevation between the points be del h and the total error be small e, assuming no error on observation of staff nearer to the level, right? So as the distance is very small, then the difference del h when the instrument at L, x1 minus y1 should be the actual reading, but there is a error, it should be detected, minus e. So y1 minus e from the first set. Similarly in the second set, the y2 is free of error, but x2 is with error, so x2 minus e minus y2. That is if we require the total error, we have to make the summation. You will get 2 del h is equal to x1 minus y1 plus x2 minus y2. The 2 will get to the denominator. That is the formula. In general, we can say first difference in observation plus second difference in observation by 2. If you want to have the error, you have to make it minus of those two equation. You will get the this 2 will get cancelled. If you add these two, error will get cancelled, right? If you subtract, these two will get cancelled. Then here it will be 2e is equal to x1 minus y1 minus x2 minus y2 by 2. Here it is plus, here it is minus by 2. So first difference in observation minus second difference in observation by 2. Thus total error in observation can be obtained by taking the difference of the two differences in the observation. So the total error consists of due to curvature of the earth, atmospheric error that is due to temperature and refraction, instrumental error due to the error in collimation. So let's have a problem. In order to transfer the RL across a canyon, a reciprocal level campaign was conducted. Simultaneously readings were taken were observed using two levels, one at each side of the canyon. Each of the levels are having the same magnifying power and same sensitiveness of level tube. Both are same. With instrument interchange during leveling operation yielded the following average readings. Find out the RL of unknown point. Comment on the errors associated with the observation. When the instrument is at x and the x RL was given, the readings taken over the staffs are 1.70, which is nearer, which is far. And when the instrument at y, so this is nearer to that. So that is these two are at the same place. These two are at the same place, right? So the distance between xy is 1.025 kilometer. Here's one equation was given. What it is, we will see in the later videos, right? So the solution is the difference in elevation we required. We need to determine the RL. So del H is equal to, we know the formula, x1 minus x2 plus x2 minus y2 by 2. Here x, that is the difference between this two and the difference between these two, right? So that gives the, it has to be added by 2. You obtain 0.56, but the how it is y lower than x from the reading itself. When the instrument is at x, the staff reading is 1.730, and at the other end, when the leveling staff was holded, the staff reading is higher. If the staff reading keep on increasing, means the leveling staff, the depth get down, the fall of the terrain happen. Similarly, the instrument is nearer at that point when y, there also the same type of reading are obtained. So from here we can observe the x is at higher compared to the y, right? So that was y lower than c. So the RL of x is given, so y RL must be lower than that. So RL of x minus the change in difference in elevation, which gives the RL of y, the unknown point. So here the two level comments was asked. Since two leveling rods are used and the elapsed time between reading in a set of this little, the error due to change in atmospheric condition can be neglected. Moreover, since readings were taken with the instrument interchange, instrumental error get cancelled. As the observations are repeated and average of the readings have been considered for the calculation, it is expected that error associated with the observation is minimized, thus removed. Only error present in the observation is that associated with the curvature of the earth. It is get compensated also, right? So I hope, friends, you have understood the reciprocal leveling and the profile leveling. We will see the next topic in the next video. Thank you.